So welcome all for today's PTC Talks, where we are excited by having Pranav Dandecker at Wings EV for a session on designing the future of personal mobility. But first, just a quick introduction by me. So my name is Torbjörn Pearson, and I'm the Alliance Manager for PTC in the Nordics, and we are running all these webinars every Friday, where we also invite customers and partners for some inspiration on digital transformation to see what is possible and how to make things happen. And all the past webinars have also been recorded to be found on the registration site. The agenda for today is first a quick overview of PTC by me, and then Pranav will run the show by introducing himself, touch base on a few challenges, how to address these, and then explain some of the business outcomes. And at the end, we are also having a Q&A session, so please keep your questions to the end. You may also put them in the chat, and we will pick them up later. So now over to the next slide, Pranav. Thank you, sir. So PTC is a global software company with a headquarters in Boston, and we are providing market-leading solutions on IoT, augmented reality, PLM, SLM, ALM, and CAD through the digital thread to help companies to accelerate their digital transformation. Now over to you, Pranav. The show is yours.
Thank you, Torbjörn. Hi all. This is exciting. I'm really happy to be here to be talking about this vehicle that we're building that we think is the future of urban mobility. So at Wings EV, we've been solving the traffic congestion problem by trying to build the vehicle that we think is the future of urban mobility and we've been at it for about 5 years. So in this talk, I'll tell you about the vehicle, tell you why we built it, then our journey of vehicle development with PTC tools. And finally, we will look at a couple quick case studies of specific subsystems in the vehicle that we built using PTC software, what challenges we faced and how we overcame them. Right? Now, to start from the beginning, right? Back in the 60s and 70s, India, like China, was full of bicycles on Indian roads. Right? And as people became richer, these bicycles were replaced by scooters and motorbikes in the 80s and 90s. And increasingly, people are switching out their two-wheelers for cars. And so you see more and more cars on Indian roads, and the cars are themselves becoming bigger and bigger. But the roads can't keep getting wider. And so what you have is a ever-growing, ever-worsening traffic congestion problem. Now, it turns out that cars and SUVs are selfish. They are great for people inside them, but they're terrible for everyone else. They make our cities less walkable, less livable, less pleasant. And so when we started 5 years ago, we started with the question of what is the ideal city ride? And we think it combines the mobility of a scooter with the safety and comfort of a small car. We think the ideal city ride should care both about the people inside and the people outside. So ladies and gentlemen, say hello to Robin. So as you can see, it's a one-of-a-kind form factor, which is tailor-made for dense, congested cities. It is a two-seater four-wheeler, which classifies in India and Europe as a quadricycle, but has a length and width of a large motorbike, right? So it can go anywhere. You can take a motorbike. You can park anywhere. You can park a motorbike, right? And now this novel sort of form factor induced a large number of vehicle engineering challenges that we've overcome systematically over the last 5 years. And I'll sort of describe to you some of them and what we did, right? So let me briefly describe our vehicle journey of how we developed the vehicle, in part using sort of PTC tools. And I'll describe it in terms of the evolving sort of form factor, right? So flashback to November 2018, and this is the very first sort of test mule that we built, right? So let me quickly play this. Now the car is not the vehicle we built. Yeah, this little thing that we built was driven by our CTO, right? And this is just like a very early proof of concept. Now, the interesting thing about this vehicle is that we didn't use any engineering software to build this. This was purely a proof of concept that we wanted to build and check whether a vehicle of this size and shape could be built. After we built this, we started doing sort of a systematic vehicle design and CAE iteration. And the way we went about it was we partnered with a automotive design studio in India. And it turned out that they were using PTC Creo. So that was our sort of very first introduction. And very early on, we asked them, okay, well, what is the latest version of Creo that we should use? And I think at the time it was something like Creo 6.0. And they were like, no, but we use Creo 3.0. And so we said, well, why do you use 3.0? And it turned out that their customers are some of the largest OEMs in India. And those customers were using, in many cases, still using Creo 3.0, which is maybe like 15 years old. And so we started developing the vehicle, sort of doing vehicle design and sort of building out the sub-assemblies on a very old version of Creo. And then, but over time, so first of all, the studio was using Creo 3.0. We had some other design partners who were using other software like AutoCAD and so on. And but we, when we signed up with PTC, we sort of got the very latest version, which by this time it had become 7.0. And so one of the challenges we had was to integrate all of these subsystems and components that were all built in a variety of software. And we found that Creo was very good at that. Very frequently, we didn't have any loss of data or loss of fidelity while integrating these things, right? And so starting in Q4 of 2018, we started our sort of vehicle development. The first iteration of design plus CAE took us to about Q1 of 2021. And the alpha protos we built looked like this, right? So this is July of 2021. We had built out 3 alpha protos after a full cycle of vehicle design plus development. And these were fully done using...
Are you showing any new slides? Because we can't see anything right now. We just have the cars and subs or selfish still on the screen here. So maybe you could just give it. Yeah, right.
Are you not able to see my screen?
We can see the screen, but I'm not sure if you're showing the right slide right now.
So I don't know if you saw this video.
No, it didn't show up, unfortunately, but we follow you.
Let me play this real quick. Right? So like I said, this is the best mule that we had built in November of 2018. And this was built completely without any engineering or modeling software. Right? And from this point, using PTC Creo, we did a vehicle design and CAE cycle to produce our alpha protos. And this is from July of 2021, right? And so then once we built these, we tested them extensively, did sort of performance testing, acceptance testing, These were driven up, more than 10,000 kilometers. And we ran extensive market research with this across 6 cities in India. And then based on that, we collected a bunch of feedback that went into doing a second iteration, a full cycle of vehicle design and CAE, where we improved upon this design to produce our pre-production prototypes, which got ready like just a few weeks ago, right? So this is what our pre-production prototypes look like, right? And so the point is to show how much effort and time and went into sort of refining the vehicle from its very early sort of proof of concept stage. And PTC Creo was there with us sort of all along the way, right? In fact, we revealed these vehicles for the very first time on stage at Micromobility Conference in Amsterdam in June this year. And we won the Best in Category award there. And we were just thrilled about the excitement and appreciation that it generated in Amsterdam. Amsterdam is already known to be a very bike-friendly, sort of small vehicle-friendly city. And we were just thrilled by the reception we got there, right? And so our vehicles are now under certification. They're undergoing that process. And in a couple of months, we will hold a launch event here in India and start taking pre-orders, right? So now let me talk about sort of a couple case studies. The first one has to do with the way we designed the battery pack, right? Now, before I describe the battery pack to you, you might have seen a standard sort of AA or sort of Panasonic cell. And these are cells that are used in many of the battery packs in the EV industry. And they're called 18650. And the 650 stands for 65 millimeters, which is the height of the cell. Now, it turns out that because of our unique form factor, our battery pack itself is quite unique. And it is so unique that its height is only 68 millimeters, right? So we think it's the world's thinnest automotive battery pack, right? And so while designing this, we had our share of challenges. And in fact, we ran sort of about 7 design plus CAE iterations. But we were able to do it in a fairly quick time, maybe a month or so, where we did the design in Creo 7.0 and then ran CAE in Hypermesh, and then came back to the design, made a few changes, went back. And the requirements from this were very severe in the sense that it had to be lightweight, and yet it had to be sturdy enough. It's a 60 kilo pack, but it's very thin, but very wide. And so you had to strengthen the enclosure in various ways while also ensuring sort of ergonomics of assembly and service and so on, right? And so this is what sort of the battery pack looks like, right? And this is a very sort of distinctive pack meant for a very sort of unique form factor. And we were able to do this sort of design iteration in a relatively short span of time, right? All of it done using Creo, right? The second case study that I wanted to briefly sort of describe was the vehicle wire harness, right? Now, electric vehicle must have a traction battery and motors. And so there is a wire harness that runs throughout the vehicle. And the wire harness must be integrated into the entire high voltage as well as low voltage line. Now, it turned out that when we started designing, sort of modeling the harness, frankly, like none of us knew how to do that, how to use Creo to do a wire harness. So we had a fresh graduate.
To interrupt, it seems like we are still on the same slide.
Oh, okay. Well, so let me just quickly show you the sort of our pre-production prototypes. And then I was describing sort of the battery pack, right? Are you able to see the battery pack slide, Linda?
We see the pre-production protos.
Can you see the next slide?
Only the 3 cars right now.
Okay.
David, case study 1, battery pack.
Okay, good. I don't know why there is this lag. It seems a bit strange. Sorry. Okay, there we go. right? So this was the sort of battery pack that we designed and did CAE, including sort of 7 iterations in just 4 weeks, and we were sort of quite happy with the way sort of we were able to go back and forth between Creo and Hypermesh, right? Can you see the wire harness slide?
No, not yet.
So let me talk about sort of designing of or modeling of the wire harness, right? So as I was saying, I mean, we had a wire harness design which needed to be carefully modeled and integrated into the vehicle. And none of us really knew how to do wire harness design in Creo. And so we had this fresh engineer who had just joined us, and we were looking for like a reasonable starter project for him. And someone said, well, why don't you like play around with the harness design part? And sure enough, he picked it up in a pretty quick time. And then he could go from sort of essentially our harness design to a modeling of it into the full vehicle in a short span of 3 weeks, right? And he was able to fully integrate the model into the vehicle. Now, of course, he was a smart sort of engineer, but I was amazed at how easy it was for him to pick up the harness design functionality built into Creo and sort of run with it, right? And that was sort of version 1 of the harness. And then, of course, as you might imagine, it went through a few iterations as our design itself changed. But I was very impressed by the fact that in a short span of 3 weeks, a fresh graduate could learn how to do wire harness design and produce something acceptable, basically all by himself, right? And so this is what our wire harness looks like with the battery pack sort of in the vehicle, right? And the point of these two was to show how, what we have is a very complex, large model of the vehicle with thousands of parts, and we have our share of challenges working with it, but the things like the battery pack design, where it required several iterations, so wire harness design, which is not like a well-known part of Creo, but is built in there and exists. We're very happy that we're able to use Creo in such a sort of deeply integrated manner across sort of 2 iterations of our vehicle design, right? So that's basically all I had. Happy to take questions. My email address is on the slide here, and happy to take happy to also take offline questions over email.
Fantastic. Thanks for sharing, Pranav. It was a really interesting story, and happy to see, what you have achieved, with your company here. So that's amazing, I think. So I had a few questions here, actually, and who is, the intended sort of customer for the microcar Robin, and why?
Right. No, good question. So the idea is that as cities become progressively congested, there is a large number of people who commute either into the city or out of the city, who live in the city or work in the city or both. And increasingly, they find it hard to find parking for their vehicles. They all want the safety and comfort of a car, but parking a car in a city is becoming progressively a nightmare. And so the idea is to think of this vehicle as your everyday workhorse, your everyday commute, where you go from your house to work and back. It's meant for city use, and it's really meant for people who value safety and comfort over and above they might get on an electric bike or a two-wheeler. So if you care enough about your safety and comfort, now these might be sort of, for example, young families, right, where they have to ferry kids around, or professional women who go to work every day and worry about safety, commuting at night, or worry about sort of the weather and dust and pollution and so on, or older people who can't deal with the sort of stress of driving a two-wheeler in town. So really, this is meant for sort of people who value safety and comfort, which is really all of us in some sense.
Thanks a lot. And what do you think about the market potential? I mean, 3 to 5 years, I mean, from now, and are you also, I mean, considering any other regions, I mean, for Robin?
Right. So we built this for the Indian market to start with. India is the world's largest two-wheeler market, where they sell 18 to 20 million two-wheelers a year, every year. And we think this could be a great upgrade over a two-wheeler. But really, this is meant for any dense, congested city around the world. And so this includes sort of most cities in Europe, Southeast Asia, Latin America, sort of anywhere where you want a sort of personal mobility for your city commute.
Right. I had another question here actually from Tim, and that was related, I mean, to the price point and the cost of the Robin car.
Right. Well, that part I will leave out until we do a launch event. So you'll have to tune in a couple of months. You'll hear more about it.
Thanks a lot. And do you have any? I mean, you have been using PTC Creo, you said, quite a lot, I mean, when designing. And do you have any ideas or suggestions about, I mean, how to improve Creo from your point of view?
Sure. Let's see. So, I mean, first of all, Creo has just amazing functionality. I mean, I come from a software engineering background, so I have some understanding, some appreciation for what it takes to build a software like Creo. So what we realize is that Creo is full of these sort of functionalities that are sort of sometimes hard to find. So if you know what you're doing, then of course that's great. If you want to explore a new part of functionality built into Creo, that can sometimes take time. And so one of the things that would be great to see is something like a chat GPT type interface built into Creo, right? Where I could ask it saying, okay, how do I check all pairs of global clearances, right? Or how do I change my coordinate system from absolute to relative or something, where it can then sort of essentially take over like go into like a demo mode and tell us, okay, click here, this menu, then go to this part of the sub menu, you will see this form, fill out these values, and so on, right? Right now, the way we do it is we have, Creo has a channel partner that we work with, and they are helpful. And so often we go to them and they help us sort of train our engineers or help us solve some of these problems, help us discover functionality. And sometimes the way they do it is they take over our computer over AnyDesk or some other remote login solution, and they essentially tell us how it works. And really what could happen is you could build in that sort of a demo functionality into Creo with a user interface that looks a bit like ChatGPT, for example.
Thanks. That's good. Good feedback. Good input. So I had another final question here. So I mean, you have a amazing, I mean, background, Pranav, as an entrepreneur, and so what is it actually? I mean, what is actually driving you?
That's a good question. Really, the thing that drives me is to see whether we can sort of make a small contribution to the world, right? One of the big problems that we face today, and we will continue to face over several decades going forward, is the climate problem, broadly speaking. And the climate problem demands not only that we switch to cleaner forms of energy generation, energy usage like electric vehicles, but we also care deeply about energy efficiency. And what we think we've built here is a more efficient form of commute, much better than a car or, God forbid, an SUV, right? And that would, in my mind, that would sort of, if we can encourage more people to use micro mobility, to use smaller vehicles, that kind of energy efficiency taken together could make a big dent in the climate problem, right? And so it's this drive to make a small contribution to an important problem that sort of drives us all at Wings EV.
Fantastic, thanks. And to summarize a little bit, I mean, from your perspective, what is the biggest sort of benefits and advantages by using Creo?
Like I said, it has, number one, it is that it is able to integrate several sort of file formats, several sort of parts and components and data that comes from other softwares, right? And that has been very useful. And like I said, particularly with respect to wire harness design, like I mentioned, a relatively new person who had never used Creo before could learn and pick up and build something useful in a very short amount of time. And that talks, that sort of speaks to the sort of user interface and sort of the power of the software.
Thanks. That's a really good answer. So time is unfortunately actually running out. So thanks everyone for joining, and a big thanks, for sharing a lot of really interesting stuff here, Pranav. So with that, I hope to see you back already next week for the PTC talks about how to leverage PLM for critical transformation and sustainable ambitions by Nucor. So stay tuned for that and have a wonderful weekend all. And if you want, you could please stay on the call and the chat with Pranav, and maybe you could take a few more questions if you have any. So with that, take care everyone. Bye. See you next week.